installed in the installation guidelines for Spark, okay, and PySpark. Now, this was done for Windows. Last time I sent the Windows guidelines. We also have guidelines for Unix machine. My suggestion is, use whatever that is your usual machine that you use. But I recommend using Unix. I recently installed it in Unix. It works wonderful. And there is a lot of other things that you can do too. Okay. I want to go through these again because the whole people that I see here in this group seems to be pretty much very different. So I'm going to walk you through again some foundations before we go into the SQL and reports generation. That's my goal. How does that sound? Is everybody feeling good about it, or is there anything else you want to tell me? Is that what would matters to you? As I said earlier in the message, as well as right now. Okay.
Yeah, I think it's a good idea.
I can't hear you. Somebody is saying something. Please type, because there's something about volume. I set the volume very high, but still I'm not able to hear. It's a good idea. Okay. So everybody is good. So let's start. Why is Spark? Okay. First of all, what is Spark, and then why PySpark? Well, now Spark is the engine that implements cluster computing in your multi-core, multi-chip computing system. It creates a parallel processing very easily. It works with Hadoop, so you don't have to worry about installing Hadoop, this and that. Everything is taken care by Spark. Very simple. Okay, and because Python is a very popular language, the PySpark is the API that connects to the Spark. That's as simple as that, so that you can use your Python knowledge. Okay. Of course, the thing is now that is better than PySpark. That is what is called the Scala. Some people say it as Scala. I say it Scala sometimes too, because it is scalable language. Okay. So Spark is written in Scala or Scala, and it provides the API to Java, Python, and R too. So if you learn Scala, there are some advantages, but that's a separate session I will conduct. Some basics of Scala. In fact, the next session will be Zeppelin workbook. This is a Jupyter workbook. As you can see, Jupyter workbook. We will also go through Zeppelin workbook. There are some beautiful advantages there, and it is you can change the languages. You can move the data from one system, one software to another software. Data from working with Spark, data from Scala, move to Java or move to Python, or data from Python move to R, from R you can move to Python. All kinds of things you can do within the same workbook. That is the beauty of Zeppelin that I want to introduce later. Not today, next session. Now, PySpark is written, as I said, of course Python, but then connectivity is to Python. It is the original Spark is written in Scala. You need all these movements between various software. It helps. Okay, and I have a 12-core machine with 16 GB RAM, and it is 30 GB unzipped data that I worked before, and on this workbook. But for quick running, I selected one file. Okay, last time I did work with 30 GB. Now I want to show some quick turnarounds with one file, which is around 500,000 records. There are, for something like around 100 million plus records. Okay. All right. So, so this full workbook I'm going to walk you through. So hopefully it will run fast because I'm taking a small collection. So now I'm going to clear everything because I ran all these things. I'm going to clear everything. And then kernel cell type clear outputs. Okay, current outputs clear, but I want to go to the restart and clear output. Okay, everybody good? Let's do that. So now it starts with 1. So I'm just checking and showing that the Python that I'm using is 3.7.1. Okay. So if you run this one, import find spark, you don't have to worry about the path being misplaced, this and that. So let's run that one. It helps you to do that. And then I'm initiating, so I'm just repeating this one here. I don't need this really, but I have the pip here, so let me cut it out. I don't need that. Now let me rerun this one. Okay. So initiates that. Before I go to the session, I want to talk to you a few things, most important terminology that I've used. Spark context. I'll be using Spark context. That's an entry point into the Spark functionality. Okay, and natively all data are stored in what is called the resilient distributed data set format in Spark. So it's also called RDD. Okay. So that is what we will be working with as a starting point, but then we will move into data frame because everybody knows about data frame, and not only data frame, but also there is some other concept called data set. But I won't use the word data set format, but RDD format and data frame format. Okay, RDD is the local native format for Spark. Okay, so let me show my unable to share. Okay, fine, that's fine. There is also Spark config, that is instantiates with certain parameters, and also called also what we have is called the Spark files. Okay, these are all the only most important thing that you need to know for now. But when we do SQL, we can use any one of these stuff like the main SQL context, that is main entry point into the SQL, PySpark.SQL context, and PySpark. And then how do we work with SQL, PySpark SQL with a data frame, work with specific columns, specific rows. You can also work with Hive data set, Hive data store, which is a super large data store available, and PySpark works with that, with this functionality, with this function, with this package part, that is PySpark.SQL.Hive context. And then grouping data is very fundamental in SQL. So that is coming from this one, PySpark.SQL.Group data. Of course, NA for not missing values, also functions are also available, and stat functions are available, regular functions are available, data data types access, different types of data types access are available, as well as window functions, which is useful for oftentimes time cuts. Okay, windows are used for time cuts. Okay, now let's start this session. Okay, PySpark SQL Spark session. From PySpark SQL, I'm going to take Spark session, and Spark is considered to be build or builder. The subpart is builder, and then it will help me to get or create the data sets. Okay, so let's run this one, and then every time when you do that, you have to stop it. So that's why I do this. I don't need to do this. Okay, so let's just. It's okay because I'm. Let's keep it. I just wanted to keep it as it is. Let's run this one. So I just initiated, checking it out, that it is working. Okay, that's all I'm going to do. But when you do the setup, it takes time because it needs to work with various subparts like Hadoop, as well as the SQLs, SQL engine. All these things are being set up right now with the right compute nodes, and also the clusters, the partitions, and so on. Okay. Now I can run this one. It will take a little bit of time because I'm using 100 million records, so maybe I won't do 100 million records. Just I'll do 10,000 records. I'll create 10,000 samples, but I'm parallelizing that. See, you can this one. I'm parallelizing it and then calculating the sum of squares with whether to find out the pi value. I'm using a logical idea. Just it's a sample that it's all working. Okay, logical idea that is if the value is less than 1, then you know that it is inside the circle. Okay, yeah, I take two random samples x and y, we uniform random sample between 0 and 1, and then I calculate this circle value, the value of the boundary circle value, and then I'm checking it out whether it is within 1 or not. Okay, that means within the square or not. Then based on that, how many times within the circle versus the square will give me the pi value. That's a very simple way of calculating pi value in the simulated way. So I'm just running it. Okay, well, let me see. It is running right now. Star means it's running. Because I only put the 10,000 samples, it should come out faster than as usual. Okay. But remember, it is doing some parallelization, all those things. So let's just, it just calculated that because it's only 10,000 samples, it calculated this value as 3.114, very close, but not a perfect number. But anyway, it is just to show that it's working, including parallelization. Okay, and then I created that SC also, PySpark context get create, and then the creation is to parallelize it, with the number of samples. And then I stop it again. Okay? So now I'm going to recreate again the SC whenever I start. Now from now on, I will keep it up. So I can do all these things, not just do this one, which is again, I'm taking not just a different data set. This time it's a different data set. I'm taking a created data set, a small data set just to show things are working, how it's working, parallelizing all those things. I can recall a specific number from which division, which partition, and so on. Okay. Now you can see that it's a RDD data set, so resilient distributed data set. I can also do this one using that data set. I'm going to do, very ordinary Python programming now. With that data set, I can work with Python programming. So that's the beauty of PySpark connected with the Spark using which because it gives you the foundations of the full Python. Even though it may not be 100% full Python 3.7.5, that is 3.7.1 that I have, it has enough for the Python work that you can do with PySpark. Okay, so you can, what I'm saying, once you load the data, you can use regular Python functions on the data set. Now let's move into the SQL. That's my main point here, main purpose here. So move into the SQL. So it's now set up for SQL. I'm creating a tuple here. Okay, I'm mixing, PySpark, SQL, regular Python data structures, all those things. Okay. So far, are you guys so far with me? Everybody is just following. Is it too fast? Everything is okay. You're able to, connect with me. Please give me some input. Okay, because I kind of talking many things here. I know Spark, PySpark, regular Python, and RDD internally, parallelizing. All those things are happening here. In fact, a senior data scientist, in fact, a senior data scientist can start their day with the PySpark. You don't have to go just with Python. Okay. You can start with PySpark depending upon how much data you have. Of course, if you have smaller data sets, you don't have to do that. But if you are working with a huge big data sets, start your day with the PySpark. It's okay, because you can continue to do your Python work also. So, so once you create a regular Python data set, you can convert it into your RDD. Okay, that's what has happened here. Okay, you can convert it into an RDD. It is done. And then you can, work with the RDD type functions. Look here, I'm taking the row functions and then, working it out and then printing that using the map. Okay, RDD map. So I'm moving data from regular Python data structures versus the PySpark data structure, which is RDD. Fundamentally, PySpark data structure is RDD. And I can move around these things. I can also move into pandas. Okay, you will see that later on. So this structure PySpark gives you full Python functionality, Spark functionality, RDD functionality, data frame functionality, as well as the data, pandas data functionality. You will see that, okay? And once we get into that understanding, so I'm going to create a data frame context now, okay? So I am moving, again, I'm telling you that I can move the RDD into a data frame, okay? So it's working, it is working within the SQL context. Now, once it is there, I want to see what is there, what are the variables, what is it, is it nullable, what is it, integer or, data types, integer or character, all those things. So let's do that. It says in this case, I have age and name because such as, this is the artifact of this one, whatever I created here, right? This one, right? So age and name. Now, I'm going to read a little bit more data. So let me read the data, what is called adult data, which is about information regarding, yes, is the question? Please type. Hello? Is there a question? You can type, okay? All right. So it is done. Now, again, it usually resolves itself, the schema. Okay, so let me see. The schema is there. I don't need to collect, I don't need to do additional steps. If the schema doesn't come, you can do this one, but schema should be there. So now let me read that. So I may have sometimes those issues. So then I do this, which is header is true, infer schema. Okay. Let me print schema. Okay, cool. Now I got the schema here. So it tells me that it has age, work class, final weight, it's a sampling weight, education level of the individual, education number of years, marital status, occupation, relationship, race, sex, capital gain, capital loss, work hours per week, native country, income. So it's just basically some adult data set about education and income, education, occupation, and income. Okay, that's what it is. So now, it is that, remember, what is this, you have to keep in mind, whether it is RDD or data frame. There is also called the data set, which I won't talk about it. It is, it is in between data frame and the RDD. RDD is the very native data set within PySpark, okay? But data set is, RDD is a lot more, native set in the sense, it's a lot more away from data scientist. But data frame is perfect data scientist, right? But data set, combines both the functionalities. But we'll work today with the data frame. Okay. Is everybody good so far? I will keep checking like this once in a while, just to make sure that you are with me all the time. Okay. Please give me some input. Renee says, please, everybody should say, whether you are with me, are you following all these things? It's a good input for me. Otherwise, I will have to slow down. Maybe I will explain, and you can ask me more details. Okay. Only Renee said, can you please a few more people? Everybody, you guys, a few folks are good. Okay, Raghuvaran says good. One more, at least Karthi says good. Okay, good. Keep giving me input always, okay? The youngest here. Okay, thanks a lot. I'm only in 10th. What do you mean by 10th? Oh, really? You are a high school student? Are you saying, is that what you're saying? Wow, where are you joining from? This is a story. Where are you joining from? Chennai. Okay, welcome. Super. You have to talk to us, what interested you to come and join a Spark session. You are an high schooler. You are attending a Spark programming. Super. Tell me, just to give me a one-liner quickly, if you don't mind. You are an encouragement, Renee. So I'm very, yes. Okay, fine. As well, I have an interest in program. Super. Okay. I hope people are honest with me. You can say anything. That's a problem with internet, right? But I take the message that you'll be great at this age. You are talking about it. Spark programming, wonderful. Okay, keep it up. All right, let's keep going. So we have here the dataset schema. That means basically it tells you, the variable name or attribute name, what type of data it is, and whether it is, null is available or not. We can put a null or not. Now let's just see the data. Okay. Now I'm just asking for 5 rows. I'm just asking 5 rows. So here it is. 5 rows. But you can see that it's a kind of very rustic, raw print form. Okay, that's okay. But if you want a better format, then you have to move it to data, data and pandas. We'll see. We talked about it. So let's go to the. So I can do some work, right? I can create functions on the. Everything is now good. We can just work with the regular Python again. Okay. But in this case, I'm kind of selecting specific column because it is still a Spark file. Okay. So there is a function I use, df with column, and cast type, new type, and so on. Return df. So that's done. So I'm going to do some additional work, other types of work. So I'm selecting some only continuous features, continuous variables. Okay, I selected this capital gain, education number. These are all continuous variables. Okay, so I selected them. I can collect and convert them into float type. These are all different types, but it just so happens. Let's see. So, for example, capital gain is okay. This is okay. Occupation, education is integer. Final weight is integer, age is integer, work hours is integer. Okay, let's see. So I can convert that to float type, df string float type if something is not working. What is happening? Wait. Call continuous features. Is it done? One more time. Maybe I didn't do something before. That was the problem. Df string is not defined. Df string. Okay. Df string is. It was all right before. But I skipped one thing. Okay. I skipped one thing. This I didn't do. That was a problem. Everybody get it? I'm going back. Now I run this one. It should work now. It should work. Now, especially the next one. Okay, it worked now. Okay. So there are things I can do like that right now. Fundamentally, what is happening in SQL? Few things. We select columns. Please listen, everybody. We select columns. We do some counting. We do averaging. You do maximum, find maximum, minimum stuff. Standard deviation. You can do statistical function. You can do mathematical functions. And then we can filter data. We can group by, filter, select, mutate, group by, and apply function. This is what we do in SQL. Everybody agrees with me? Rene says yes. Super, Rene. Everybody agrees? Mihir says that's all we do. What is that we do? We do group. We select, filter the data, do group by, do apply functions. Mutate function, mutate also, mutate attributes. We select, we mutate, we group by, we filter, or maybe in the order select, filter, group by, select, filter, mutate, group by, right? And apply function. This is what we do all the time. We also do what is called create cubes and roll-ups, and sometimes use window functions. This is what we do in SQL. So there are two ways to do that. We can actually apply. How many of you know SQL? How many of you know SQL? A little bit. Rene says a little bit. Okay. Angel says +1. Okay. Excellent. Okay. Very good. A lot of people know. So whatever you know SQL, you can just go and drop it into the query. The SQL query in Spark. Okay, that's the simplest part. Thank you, Ovizo. That's the simplest part, right? The second part is you can also use those group by functions. Group by functions separately are available. Filter functions, select functions are separately available within PySpark. Okay, so you can do the same thing with or without the regular SQL. Okay, so let's go through some of this today and create the report that you want. That's what we are going to do. Okay, so here is a function called describe, which is similar to Python describe. Okay, so I take the df data set, and before that I am going to do count by let's show this one select. I'm going to do select df select. Let me do this one also. Make sure that it's all done. because otherwise I may get into some difficulty. So let me run this one, this step, okay, and then select. I can just select. So it says age. These are the age of the people only for some reason. Not these are the only ages, but these are final weights is not counts. It is the weight, sampling weights. Okay, in the country, you can call it as in the country. There are a lot of young people are here and old people are also here, but 39 is not that much. Okay, so I'm only showing five records. Okay, so Spark is a lazy functionality in the sense that you have to execute the function or the method, and then you have to collect or show. Otherwise, it will not do. So if I don't do this one, it will simply execute it, but nothing will happen. It will simply say, oh, it's a data frame. It's about age, integer, and then final weight. These are the two columns are there. Age is integer, and final weight is also integer. So unless you put collect or show. Collect means it will collect and keep it, but still, if you want to see, you have to show. Okay, there are default number of values also there. So I'm going to do this. Show 5. Now it shows 5. Okay. Now we can also count function. So group by functions, and then what do? We want to group by all the sample by this variable education levels, and then do the counts, and then sort the count, and then sort the count by the ascending true, increasing true, right? So let's run this one. Is this clear to you? Very simple, right? It's a function of a function of a function you are going to do, right? Methods used to, the methods is show, and then that is used for what? After the sort value is done. For sort value is done for what? It's for the count, account of what? The grouped values by the education. That's what it says. So this is the that you have similar to SQL. You can do SQL also the same thing. We'll come to that at the end. I'll show you. So it says preschool is 151 people are there. First and fourth graders are 168 people. It's very interesting. They have done only preschool. That's what it means. It's that adult data. They have only done only up to preschool. People say 168 people have done only first and fourth grade and so on. There is a high school graduate is 10,501. So like that. Okay. So you see the frequency basically, right? So you have done a frequency education level summary of counts, okay, and it is it's basically ascending is true. So that's why the first one is you got this way. As you increase, as you go down, you are increasing the counts. So I can do more. Describe gives me more. Describe I didn't explain it to you. This is just a group by example, select example, group by example, describe. So describe gives me box plot type data. Okay, you know what I'm talking about. Box plot type data, which is minimum, maximum, average. Let me see, count, mean, standard deviation, minimum, maximum, all those stuff. Those are the things that use if you do the describe for every variable. Remember that. Okay, but again, it's not very convenient to read, isn't it? So let's do one thing. Maybe we'll convert this into data, pandas data frame, and see, because see, original data is summarized. Now this is a very short small file, isn't it? Do you agree with me? Describe will be a short small file. Describe data set will be a small file. Agreed, everybody? So I can use pandas on that one, but the original data may have billion rows. Okay, are you with me, guys? Give me some input. Renee says, thank you, Renee. You are super fast. I appreciate it. And all the other people who are also giving me input. I love to interact with people, and this is why it's fun. Speaking with you guys. Okay. And anyway, I got 5 input. Okay, thanks a lot. Please don't hesitate to engage. Okay, thanks a lot. All right. So before I go into the pandas, and you can do all the other regular things. I'm going to still talk to you a little bit about managing the Spark, right? What is meant by the memory, how many executors, how many partitions you can do, and so on. So a little bit of distraction here, but just good to know what's going on. So I set up 12 G of RAM for the I configured it for the Spark session, and then I'm giving myself 5 executors. In this case, the executors will be the core actually. All right, and I'm going to read a bigger data set, a airline data set. Last time I did read the whole data set, but this time I'm going to do only short data set because I want to execute and show it to you. Okay. All right, so let me run this. It's not bad. It will take 10 to 20 seconds because it's 500,000 observations, and it is going to use a read through SQL context, read format as a CSV file, and then options are header true, and it asks me. I'm asking it to infer the schema, and it is done. 13 seconds, it is done. And let us see. I don't want to run this one. This one will read the whole list of files, which is 30 gigabytes. But I already have what I want. Okay, so let's see the schema. So now year, month, and you can see all these things again. The attribute name, what type of data it is, whether it is nullable or not. Okay, so I got a lot of data here, and I want to show just show means it will show me some number of records, sample number of records. So that's what it is here. Because there's a lot of variables are here, it is showing me, looks like it's a lot of data. It's not really that much. Okay, 20 rows. This is the default for Spark context. 20 rows. I usually see 5 or something like in that range. R gives me default 6 rows, right? Okay. Now I just want to do the count. Count is very fundamental. So just do that, and I mean, there seems to be a lot of lines here because I want to show how long it takes. It was very interesting in the previous session. Also, for comparison purposes, it's interesting, but just for a quick move around, quick going around various functions and functionality, I'm kind of reducing the data set here. So this may not mean much now, but I was doing last time. It was very valuable. Okay, comparing times. Now it did count, and then it says 448,000 records are there, very close to 500,000 records. Okay, one file, and there are something like 303 files I had. So whenever you have, you remember DF is a data frame. Okay, SQL data. It's a Spark data frame. Okay, it's a Spark data frame, DF. So I can use the functionalities of whatever I got from Python to use it on the data frame. So describe is a function, you can use it, and I'm going to select only the describe all the DF count, right? But I'm going to do just for arrival delay alone, okay? And then I'm going to capture that into puts it in the D1 count. Okay, I call it as D1 count, and then I will print df describe and D1 count. Okay, that's fine. Let's just do this. And it started running, and then it just printed out. Because it is a describe as count, mean, standard deviation, minimum, maximum. Okay, so it says arrival delay for the 444,000 records that I have, which is for for one particular month in a year. In a particular 1987, I think it starts. Starting year for this data is 1987. And then the mean arrival delay is 6 minutes. Standard deviation is 18 minutes. Look at this one. So it's highly unreliable, right? Because it is 18 minutes of standard deviation. Nonetheless, the minimum is something is not clear what happened here. So there are some data issues. You have to be very careful. Delay cannot be minus, right? So anyway, the maximum is 860 minutes. Now I can convert this. Remember, I told you I can convert this to pandas. Let's convert the DF data into pandas. Okay, so it's doing that. Oh, this is going to be a problem because you know what? I shouldn't have done it. It's really taking the whole DF data, converting it to PF pandas, which means 444 lines of records are being converted to pandas now. That is going to take a lot of time. Okay. I can kill it, but let it go. Let it go. No. Right now, then when I do the type, then it is going to tell me the pandas data frame. So I'm going to stop this. It's okay. So interrupt right now. Kernel interrupt. Okay. If I do that, then I have to start all over. I don't want to do that. Okay, so let it go. And in the meantime, I will explain some of these things, and then we can come back and run these things faster. So I can move between data frame to RDD, RDD to data frame, RDD to RDD to pandas. I can do all kinds of things. Okay, so that's what it is. I'm doing here. But as I said, I cannot execute this because right now it is converting into pandas. Okay, so then I'll go back to RDD. That's what I'm saying here. Okay. But then after that is done, I want to know how many partitions are there. So I'm defining, I can also define number of partitions to any number that I want that is suitable with my memory management. So I'm doing it 310 because I was working with 305 files. You remember 303 files? I just want to define more partitions, like 310 partitions, so that these are all just raw data stored there, right? Managed there. So it is okay, we can do that. And then I can also find out how many partitions are there. After I do this, I should be able to see 310 partitions, as I asked. And then I can also unpersist the number of partitions I have created, the RDD functions, whatever I attach to RDD function, I can unpersist. That means I can remove all those things, go back to the original, and then you'll see executor count is 0. There is nothing, no setup is there because I unpersisted the DF. Okay. Are you guys with me so far? I'll come back and show these things. Let this finish. I'm waiting for this to finish because it's a large file being converted into pandas. It's not a good idea what I did. I was checking something. No, it's okay in the test process, but to show it to you, not a good idea. But anyway, it's done. I cannot. If I do it, undo it, then if I kill it, then I will go back, start all over. So I don't want to do that. So my question is. My question is, are you guys with me? So, okay, there are 2 questions here. In real world scenario, how can we deal with such data issues? Should we just drop those rows? Not clear. What do you mean by just drop those rows? Oh, you mean the data quality issues? Is that what you're talking? I think the minimum 1,000 minutes on that row you are talking about it. I think it's a good question. Let me just verify. Yes. Okay. If the data doesn't make any sense, you have to figure that out. There may be some issue with the data, why it is coded as minus 1,250. There could be a miscoding or whatever it is. Most likely, this is a useless data because it doesn't matter if it is miscoding or real coding. That's not part of our analysis, so it should just drop. Okay, excellent. The second question I have is, so does it just to show 300? It will show afterwards, in a moment, but after I do that, right now I converted them into pandas. Okay, does it take a long time to convert pandas? Because it's a large data set, it's 500,000 records. That's why it took time. Okay, so you can convert them into pandas for yes, summarized data set is much better, but you are not supposed to work with pandas. You can work with pandas after you summarize the data or reduce the data. Are you with me? Otherwise, don't work with pandas because you have all those functions available in Spark, PySpark. Okay. Okay. So that's what it did. You can see that it printed some sample files and then it went to the end of the file. Header 29 records, the tail, around 30 records. It printed again. Around around 29 records, 30 records it printed. Okay, header and tail only. So if you see DF will be data frame. Right? Type DF is, it says for SQL data frame. You see this one? Okay. But we can go back, as I said, RDD. Let's go back to the RDD format because I should be working only with RDD. Number of partitions, I want to see what is the number of partitions. Right now it is only 4. Okay, standard partition, it defaults, it calculates itself what it wants to do, what is the right thing to do with my system, and so on. But I can, under some conditions, I can do always, I can always do repartition it, and then if you ask for partitions, it says 310 partitions. Now 310 partitions are, they take the 12 gigabytes of RAM space. See, remember, Spark is working in the RAM. Okay, it's in-memory computing platform. So it divides the 12 gigabyte of RAM for managing the partitions and computing and PySpark and all those things, plus also equal number of megabytes for 310 partitions. Because it is reading the data is just a partition issue, it's not a big computational issues that are happening there. I just wanted to test the speed of it, and that's what I did in the previous session, and I'm recalling this step. Okay. Now, data frame is better than when working with structured super large data. but don't convert it into pandas. You can still use data frame, but don't have to work with RDD, okay? But don't move it to pandas. Now, I want to unpersist now. I removed it. Now you see the counter will be coming down to 0 and 1. Name executor count is not defined because something happened. I know we did SC is not defined properly. Oh, I did not do it. I took it out. I think SC is defined now. It is okay. Okay. Is everybody okay so far? Guys, please give me some input quickly. Renee says yes. Thank you. Just jump in, talk to me, folks. It's very, very important that you keep giving me input. Okay? It's it may not take any time. Just do that. It's helpful. It's fun for me to receive. All right. No, as I said, I just kind of took a small digression about partitioning. Working with again RDD, moving data from one format to another format, and so on. So let us do now the SQL type summarization, selecting group by, having order. Order is same as group by. I'm sorry. Order is same as sorting here, right? Applying aggregate function. These are the common things that you do, and we can do these things with our spot data straight away. Okay. So here is describe again. I want to do that with the DF data. I take it, and then describe. So it's a small file. It's some of them repeating. Okay, here it is. Take a lot of time. Probably 10 seconds because it's working with 500,000 records. It will take probably 10 seconds. And then let's show this. Okay. After it is done, we'll show what is there. And it is hard to read. That's the position I'll take. And then I will convert it into pandas. Now it looks so nice and beautiful. Okay. But it is a summarized data, so I can do that. Describe it as summarized data. So it's still working. That's fine. Maybe it will take 20 seconds. I remember last time. So any questions in the mean? Okay, it is done. It took 43 seconds. Sorry. Now I want to see only the top 10 of the described. So this is what it looks. It's hard to read, right? It's so funny looking data. It's a raw data. So let's convert that into pandas. So boom, it did it. The conversion is also very fast. You remember it because it's a small data set. Okay. And as I said, it gives me count, mean, standard deviation, minimum, maximum, all those things for all these variables. And so if you have tail numbers or characters, so it's not going to give anything for our character variables. Remember that. Now I just want to see the top 5 records of DF limit to pandas. I'm taking DF only 5 records. Then it's okay. It is fast. Okay. So you see this one, it's now working with the record. So you can, if you instead of putting the whole thing into pandas, if you do just, you want to check it out because it's easier to look at it, makes sense and so on, to sample values, sample works, sample related works, then you can do it to pandas and it works very fast. Now if you see DF type, what is the original DF type? It is still the data types are this one, which, I told you is similar to schema information. Okay. All those things are coming back here. Now I want to take the DF describe into pandas. DF describe is already there, done. So let's see. So it is already there. So DF describe is already there, and I'm taking it for all the variables, right? And there are a lot of variables which are qualitative. It's not coming out. I just want to know. This is called the summary. This column is summary. So I can also. So once it is the pandas, I can do all those pandas related functionalities. That's what this one is. Summary means select a specific column. So it's going to do for me just, that specific column has these values. That's what it says. And this is what it is. Okay. I can select any specific column, do transformations, all kinds of things I can do. Locations, specific value, maximum of day of week. Maximum day of week for the variable day of week. Okay. But it is available maximum means in this row. So this is a pandas application. Are you with me, guys? Are you with me? Do you see what I'm doing? I'm working with pandas right now. Pandas application, pandas way of selecting, transforming, mutating, all things I can do. Just panda, work with pandas type, you know. Okay, and now I want to go back. Now describe now. I don't forget about this. I don't need this. Okay. There are a lot of aggregate functions you can use. I don't need this. I mean, it's basically the same thing. You know, there is no. It's just a empty setup right now. That's all I'm saying. No need to worry about that. So I can do all kinds of other functions also. Like, you know, I can pivot. I can sum. I can do percentiles. You know, all those stuff I can do. So here is an example of group by. I'm going to use group by. Group by year, month, unique carrier. Carrier means it's basically the airline name. Airline name. This is the airline data, right? And then I'm aggregating by arrival time, maximum arrival time. I'm only aggregating maximum arrival time, but by these variables. If everybody's good, I'm grouping by this. So for every year, for every month, unique carrier, you know, a particular airline and its arrival delay, maximum arrival delay. That's what I'm doing, and then I'm sorting it by the column called maximum. The summarized table will come a column with the column max arrival delay. I'm sorting by that one. So let's print that one. Do the work and print it. So here it is coming. So you can see that, you know, it is sorted maximum arrival delay for the year, because I took only the year, you know, 1987 month, you know, the October month, you know, I will have only this, you know, I don't have other. This is 500,000 records, okay. So, but if I have run, you know, read all the data, 30 gigabytes of data, it would do this for every year, for every month, for every career, okay. All right. So, and then I can also, you know, do the, as I said, do the select, filter, mutate, summarize, arrange, which is what is called the sort, and then do drop NA, drop fill NA, the missing values, okay? All those things, which are all functions of, you know, the data frame of the RDD. There's a difference, remember, data frame of RDD versus pandas data frame. Okay, I'm not, this one is DF is not pandas data frame. Okay, DF is the original data frame from the RDD. Is everybody good? What I'm saying? There's a question. Can you specify the airline so that the data we get is only for that specific? Oh yes. Okay, you can. You can specify the airline also. Okay, you can do that. It's basically the it's basically fixing the career name. Okay, so that's what selection means, right? Okay, selection means. Now so remember, this is what is this called? Anybody can tell me what is this kind of structure is called in Python? Anybody wants to say that? I'm right now in hardcore programming, Python programming. Hardcore Python programming I can do with the data frame of the RDD. What is this one? What is this called? Something called this type of working with this type. Okay. List comprehension. Excellent. Vishwa, you are super, man. So, super. Thank you very much. Yes. List comprehension. You can do list comprehension. You can do dictionary comprehension. You can do generators. You can do all kinds of things. Okay. So that's what I'm doing. I'm just showing that you can do it. Okay. And then DF data type. Again, DF columns. I'm selecting the all the columns. I'm using now set operations. You see this one? I'm using the set operation and converting it into a list. These are all hardcore programming, lambda syntax, exactly. So you can do hardcore Python programming within the PySpark, PySpark related RDD converted into data frame, which is not pandas data frame, okay? Because if it is pandas, it cannot handle, but it can handle in the Spark data frame can be handled, even though you may have a huge data set, as long as you have the enough memory and you have the enough, CPU, the network clusters attached to it. Cool, very cool. Isn't it exciting so far? I mean, we have graduated quickly, the interconnections of the Spark, Python, RDD, data frame, pandas, partitions, everything is coming together. And then we are applying SQL type functionality. I haven't really done the hardcore SQL yet, but all those SQL type functions I can do this here, and the hardcore SQL also, it's coming, okay? It's coming. I'll show it to you in the end. Okay, so I can now, this is another hardcore, Python programming, star column zone means, all the things that are available here, okay? So it says column one is defined these variables. I then take that, and then I'm also adding the arrival delay and arrival time to that, okay? I'm adding those columns and then sorting by the air delay, air time, and assigning to all those things, okay? Now comes, somebody asked about, can I select, specific airline name? So you can see that this is, it's showing only 20, but remember it is selecting, sorting, and printing all those things, okay? Now you asked me, unique carrier here is American Airlines alone. I'm filtering American Airlines alone, showing only the top 20, okay? Everybody is good? This is only American Airlines data, okay? Okay, everybody is good so far? Any question? Now, Miguel says yes. Please do, type. So this is the. I'm sorry, I went out. This is the. Yeah, this is the AA data, all raw data. Excellent. Yes, Rene. Right. Okay. Now the question you might have asked is, okay, now I have RDD, data frame, data set. Which one is better, to work with? So here is the good notes I have here about, before starting the comparison between RDD and data frame versus data set. Let's see RDDs, data frame, and data sets in Spark that we saw already. RDDs stand for this one. It's read-only partition collection of records. Okay, is fundamental data structure. It allows the programmer to perform in-memory computations on large clusters in a fault-tolerant manner. Okay, the speed is the task that you want to achieve. Okay, as well as object-oriented programming. On the other hand, and it works both on the structured and unstructured data. That's the beauty. Okay, but the data frame will not work on unstructured data. Okay, but the data set will work with certain careful careful applications attached. Careful applications applied to it. Now, so I'm saying here, so that is another one. RDD can work with compute engines native such as JDBC. Okay, but the other two will not work. The data set and data frame. So are you guys saying something? I hear some voice. One moment. No, is there something going? 1 second. Yeah, I'm not able to hear you guys. So please, if you have a question, type. I'm going to see because I thought I heard somebody. No questions. Okay, fine. So the data frame is not that bad. It works on semi-structured data, but not unstructured data. Okay. So there are some advantages, going back and forth. But as you saw, you can always move data. There's something about Spark specifically. It is the only, in-memory computing, large, huge data sets, working with, parallel processing, and also you can move the data from one system to another system, one data type to another data type, very easily. Okay, RDD to data frame to RDD, and also RDD to data frame to pandas, pandas to data frame. You can do all kinds of things. Okay, and also structured data, semi-structured data, unstructured data from Python to Java to R to Scala to again back to Java, Python. You can do all kinds of things depending on the situations, how you want to use it. So I think really hardcore data scientists are going to be more and more using Spark, in my opinion. Okay, and and you have no choice when you have a huge big data. That's another thing, right? So I want to do a little bit of some calculations you can do. Look at this one with column. You can do this. Isn't it amazing? I love it. So you can do the mutation very easily within within the data frame. Okay, context, and then you have to show this. Otherwise, it won't show. Okay. So that's what is happening. It's actually a number of hours, not anymore minutes. It's talking about a number of hours. Okay. All right. I can do all those things, the mutation, and then I can also do other functions. So look at this one. I take this average time and average delay. Two columns only I'm taking, and then I'm just finding out the average time, for example, and then printing it out. So it's calculating the average time. And it is printed here, okay? Not average time, minimum, right? It is taking minimum. Oh yeah, first two is minimum, next is average, next is maximum. So there must be a lot more outputs here. Yeah, there you go, average time, and then maximum time. So you can create all these reports quickly. And again, if you want a more sophisticated looking output into data frame, you can convert it into data frame and print it or create the reports, okay? So DF columns, these are the columns you have, you can work all those simple functionalities. Here it is, group by is happening here, okay, and then I'm applying the aggregate function, in this case average and maximum. Are you guys with me? This is the height of doing all sophisticated functions that you have, that you can apply. So as before Miguel said quickly, yes, please tell me. I mean, so it did. You can see that it's pretty good. It is doing fast, and we are able to apply the aggregate functions. We can apply the aggregate functions, and then it's not just aggregate function, the whole file, but by year, by month, by unique carrier. Okay, it's pretty good. Okay. And then, very interesting is I want to only print the top 10 delays of the year, in this case of the month and the year, and that particular year and that month. Okay, I just want to do that. Look at this one. I group by, and then I'm doing aggregate. You can also save the group by function and then apply aggregate function subsequently. That's what I'm doing here. Okay, so this is mean aggregate, mean delay. Okay, average delay, and then you are doing converting into pandas to see that. Okay, let's just do that. It's working right now. While that is working, let me explain this one. I think it should show. No, it may not show. Let me see. It's still, oh, it's done. Yeah, it is done. So it is done. So let's do this. I can also do, now you have a OFC meeting. I am disconnecting this call. What is OFC? But it is really a nice session. Oh, offsite meeting, something like that. Okay, you guys. Okay, thank you very much, Mr. Parvinder. Hope to see you next time. Have fun time. Thanks for giving me input all the time. I appreciate it. Okay, keep going, and then let's. Now I'll finish it. Folks, in another. Oh, it's in another 10 minutes. Maybe I'll finish it. How about that? Is that okay, guys? Give me 10 minutes. I'll finish it. Okay. And then. So this is something let's do. Okay, so I can also create I can also create cubes and then roll-ups. Okay, cubes are multi-dimensional data sets which you can slice and dice. That's what the purpose is. But the roll-ups are multi-dimensional hierarchical data set, so you can subset it. Subsetting is different from true subset is different from slicing and dicing. Everybody understands what I'm saying? So you can do that, and I have done here some work here. I can show you. It's very easy. Data frame.cube versus data frame.rollup, and you'll get the answer. Okay. So let's see whether you have anything. No, I can just show it to you that it's working. What that is happening. I want to talk to you about. Whoa. So that is happened. Okay, that's fine. Now I want to do the roll up. I want to show you something. Let me see. So roll up is also done. So it's very straightforward, very easy. Let me show you that your hardcore traditional SQL, just you have to put it like this. I have to define the Spark session like this, okay? And then I have to create a template view, create the view for the data set. And that view will take it as a table view. And then you can apply that for the flights data, which is basically the DF data, right? Data frame data, read from the original file in Spark. Then I can do the SQL, what are the hardcore SQL you have within quotes in this command, spark.sql, end of story, okay? And it will show the, right now I'm just, showing you that it's working. And then I'll do one more, you will have confidence. Select, so this is done. No, it is working, right? So now if you go to SQL unique, now I'm going to select unique carrier name, count how many unique carrier rows are there from flights, group by unique carrier, okay? Right? This is a hardcore SQL type. I can do more, but here it is, okay? So here they are. There are 37,048 records of Eastern Airlines. American Airlines is 56,091 records, and so on. This one PS refers to Ukrainian Airlines. There are 14,000 records are there in that one. Okay, that file. Very strange, because I know this one because this one has the worst delay. Something like 12-hour delay or something like that. Okay, on that month. This is what I want to share with you. So talk to me now. Questions? I think it's cool, isn't it? What did I achieve today? I achieved the following. Agree with me or not, please. You have to tell me, okay? I achieved the following. I showed you that how to start your Python Jupyter notebook and start your Spark and PySpark. Okay, PySpark is the functionality API that is written actually in Scala. Okay, written in Scala, but PySpark functionality connects to the Spark function engine, and it is okay. That's fine. But see, Renee is all about repetition. You keep repeating these things, you will be, you'll get it. It doesn't matter. Intelligence is not a big deal stuff. People will have a tendency to say, "Oh, intelligence is only some people." No. Okay, intelligence is repetition. Okay, stupid repetition is intelligence most of the time. I'm saying, okay, but there is a higher order intelligence. These are all just repetition, but there are higher order intelligence, which is the consciousness, relationship, all those things. But that it requires spirituality, all those. I'm not going there. This intelligence you can get it. No, it doesn't matter. That's my point. Okay, everybody can get it. Okay, but it's just a repetition. That's all to it. So can you explain cube and roll-up aggregation? Okay, cube, sometimes you want to do slicing and dicing of the data. Agreed? You agree with that, what I said? Yes. Now, slicing and dicing in a summarized form. Agreed? Because slicing and dicing raw records doesn't mean much. Okay, slicing and dicing in summarized form. That is what cube helps you to do. Understood? So it's like cube. Let me show it to you in picture. One moment, please. Good question. It's a little bit advanced. Yes, agree with you. Okay, cubes, data cubes, right? New cubes. Okay. The reason I want to show you is now the images can help you a little bit more. Take a look at these pictures. I'm going to show it to you. Okay. Does it? Do you understand this one? This picture? This should be fun to know, right? So this is a slice. This yellow is a slice. Blue is a slice. This green is a slice. The red is a slice. These are called slices, right? This is also a slice here. This is a three-dimensional cube. This is another three-dimensional cube. Let's just open this one. What does this say? It says roots. These are all roots. Alaska, Asia, Australia, Europe. You may not be able to see it now. It is coming now. These are roots. This is the source, air, sea, and then time. Okay. So there are three dimensions that are being used to summarize the data. But then once you summarize, you can do the slicing and dicing. It's a phrase, slicing and dicing. There is no dicing here because dicing means random, right? Maybe randomly selected. That's not the main thing. But the point is now subset it here. Is that clear? First about the cube. Is that clear to you? Okay. Video is like, so there is a problem following up. Okay, I'm sorry about that. Don't worry about it. It's lagging even for me because it takes, for example, it takes time to get the high resolution of this table. What I showed. Okay. Able to share the co-recorder and source code. I will do that, Gavaskar. No worries. Okay. Rene says, okay. Now, this is the now. What is rollup? Rollup is a hierarchically structuring the data so that you can take subsets of the data and create a cube out of it too. Are you with me? So rollup is hierarchically structured summary. So you can take subsets. Slicing also looks like subsets, but it's a different subset. Okay. And the dynamic way of summarizing is a lot more possible in the rollups. In this, you cannot undo this. That's another point. The cubes cannot be undone. But unless you do the undo, you cannot do a different resummary. That's what my point is. And that is possible in the hierarchically structured rollups. Are you with me so far? Excellent. Thank you very much, guys. That's all I have. Any other question? Any other question? Okay, no questions are there. So I'm going to call it a day today. Thank you. Thank you very much. It's fun to see you all. I'm very, very thrilled, excited that there were 19 people here today. I appreciate that. Come again. Enjoy your learning. Enjoy your friendship. And Rene, you are super. Really, you are super. If what he said is true, I'm sorry to say, what he said is true. 10th grade guy, 10-year-old, or 10th grade. Which one is true? Because you never know. In intro 10th grade, you are amazing, amazing, amazing. Look at guys. I'm impressed. Rene, you are an inspiration. Come again. Let's have fun, some fun time. Next time, I'm going to teach you Zeppelin workbook, Zeppelin notebook, which is different from IPython Jupyter notebook. And you can do a lot more there, a lot more wonders you can do. I told you that you can move data, not just within data frame and RDD and data pandas, but actually data between Python and R, Python and Java, Yeah, yes, it is available for MacBook as well as for the Unix machine also. Okay. So thank you very much for everybody. Please give your input in the meetup session. Go and say good things if you want to, and come again and spread the word, spread the love. Thank you very much, everybody. Have a great day. Bye bye. Hey, always, how are you, man? It's a long time. Okay. Keep up good cheer. So I'm glad to see you all on this coronavirus time, and meetup is usually doesn't allow, pure web meetups, but they said that, okay, guys, go ahead and do web meetup because we cannot do in person. That's what had happened. Yeah, I could not do it in West Virginia University, but I'm in West Virginia right now. I didn't go to the university there today. I have to do a pure web meetup. Thank you very much, everybody. You guys are awesome. Keep a good cheer and and good learning. Bye bye.